Cool. So thanks for making it out here. This first session is going to be covering over sheet metal, obviously. It's going to be mostly based on the basics, though. So we're going to be starting on kind of what K-factor stuff is and kind of moving on forward. I'm David Janicki. I'm an application engineer with Fisher Unitec. So just a quick bio about me. I've been using CAD for about 6 years. I started in school working with like Autodesk, CATIA, and NX. And then professionally, I've only used anything but Solidworks. So I kind of like it that way because I've kind of liked Solidworks the best out of all the ones I've tried. So it's just kind of about me. Joined Fisher Unitec in 2015, kind of towards November. So started to get a pretty good grasp on things and kind of how everything goes. Mostly I'm out in the field though doing demos and then in the classroom doing training. And then obviously coming to these things. So can't help but give a shout out to Western Michigan Broncos. So if anybody in the room is an alumni here, go Broncos. This is my lovely fiance getting married in June. So exciting stuff. And our dog Sydney dressed up in Hawaiian suit, just a party animal. So just who I am. A little bit about me. So,
David?
Yep.
Jeff is here.
Awesome. So quick intro. When we start going over some of the stuff on K-factors, Jeff might jump in just to give another industry perspective on kind of his thoughts, just another opinion. So he's from Royal Sheetmetal. I think it's Jeff Kooienga, right?
That's correct. Yeah.
Awesome. So cool. So we'll have him jump in at some point as well. So, but this is going to be our agenda for the night. Going to start off by talking about those tables, understanding them, knowing that there's a difference between gauge tables and bend tables. So those are two things that can be distinctly different. And then we'll take a look at some things that you already have access to as your custom properties. There's some pretty cool things in there that you can actually get information from. And then we'll jump into kind of what the state of sheet metal features are. So, I mean, since this is going to kind of be basics, I'm just going to start from the very beginning and kind of what these features are and how they can be used. And then from there, we're actually going to get in and actually do a demo of it. So you can see kind of how they're used and some kind of implications of the features, the different options you got. So we're starting off with kind of understanding your table, right? So when you're thinking about gauge tables, bend tables, a lot of all this other stuff inside of sheet metal, just kind of some vagueness and kind of what all it means. So what even is bend allowance? What is it to you? What does it mean? What did I do with this clicker thing? Okay. Bend allowance for the most part is kind of a general term used for the values used to calculate your flat pattern. So when you're actually forming those bends, how do you actually get it back to that flattened state since there's tension and compression happening on these things? So you kind of got all this stuff happening over here whenever you add a bend to it. So there's a lot going on whenever any bend is thrown into a part. So what is the goal of finding that bend allowance? It's to find the length of that neutral axis. So it's kind of this. I can't even hold my hand straight here. I'm going to try. This little piece right here. So it kind of varies depending on thickness, depending on material, and a lot of these other factors. And it even varies even more once you start getting into the various types of bend allowance. So we've got, I mean, these 6 or so different types that we can actually use to get to it. So there's kind of a lot of variety when you start getting into sheet metal, how each company uses it, how each industry even uses it. Because when we're talking about sheet metal doesn't have to be actual metal. I mean, it can be cardboard, can even be fabric if you really wanted to get down to it. It's just kind of those things where bends are applied. It's kind of thin material, getting into that stuff. So we're going to get more into this though. That's that bend allowance kind of in that flattened state, so you can kind of see it needs some calculation on how it actually unravels. So when we actually start getting in these tables though, we're going to be talking about 2 of them, gauge tables and bend tables. So understanding your gauge table. So there are 2 main types when you get to gauge tables. There's going to be simple, and then there's going to be combo or hybrid tables. So this is going to be the simple one on the right, and when we're talking about simple, it's basically just concrete values that you set, and it's going to be kind of driving one distinct K factor. So that's kind of that 0.5, and then it's dependent on your gauge values that you have listed and kind of that gauge thickness and then available radiuses for you to actually bend to. So this is going to depend on which material you're obviously using, but this is kind of that simple one. Once you actually get down into gauge table / bench table combos, that's where kind of that you're getting some gray area where those two are actually starting to combine into one instead of being two distinct ones. So it's actually going to combine both of those tables into just one. And if you're ever wondering a lot of the times why the heck you even need Microsoft Excel, this is kind of one of those reasons right here. All of this is based inside of Excel, and all these tables are driven from various things inside of there. So a lot of times people are like, why the heck do I need to pay for that? I don't need that. This is one of those things. And that kind of comes into play a lot when you actually want to create your own, especially so. But inside, sorry, I got a topic there. The gauge table, bend table hybrid. It's combining that bend allowance and bend deduction table so that you can kind of specify your gauge value. So we're looking more so down here where you're setting your gauge and you're setting your thickness, and then it gives you some room to kind of, if you've got certain bend angles that you're driving by, that's where some of that's actually going to start to change depending on what you're actually choosing. So we're talking about creating your own though. So this is probably what a lot of people end up doing, because why would you want to have all these gauges if you're not using them? A lot of people only end up using a handful of various gauges depending on your industry. So you can create your own, kind of cut out some of this other stuff that you don't need. One thing I do want to make sure you know is try to save a hard copy of whatever one you're copying it from, so that if you ever mess this thing up, you get in there and start tinkering around and moving things in the wrong direction, or maybe it just blows up on you. I don't know. It's always good to have that safety thing to just start back from if you need to, right? So it's easy enough to just kind of take one of these, copy them over, start finagling it. One thing you do want to make sure and abide by though is keep all of your decimal values the same. So don't have like certain things at like 4 decimals and then some at 3. It just kind of it will cause some errors down the road, and you don't really want to have to deal with the implications of that. So that was gauge tables. As we start to move on, we kind of mentioned bend tables a touch, but they can be their own distinct thing. So if you're using a simple gauge table, just one that's only got kind of that gauge number, gauge thickness, bend radius, you're then also going to be able to use bend tables as well. And this is where kind of some of that K factor, a lot of that other stuff that you are always like, what the heck does this even mean, start to come into play. There are 2 different types. So you're going to have simple bend tables and varying bend tables. And we'll start to actually see what both of those look like a little bit down the road here. But these bend tables can actually be driven by K factor, bend allowance, bend deduction, and then the rarely used but still available bend calculation tables. So what's actually driving these things? What are all these values? So I'd love to say that I've got a super simple, hey, this is K factor for you. This is what it is in 5 words or less, but I don't. K factor is just kind of that ratio that represents the location of the neutral sheet with respect to the thickness of the sheet metal part. So that's just kind of a decimal. That's relating where that actually, that point where no compression or tension is happening with respect to the thickness. So this is kind of one of those things that starts to change depending on material, depending on I guess thickness of the actual material as well. So usually, and I talked to a lot of support people about this one, and there's a lot of times where they'll start trying to go in there and tinkering with that K factor number. People can't really get to a good solidified spot. Maybe their flat's coming off a little bit wrong, their blank's just coming off wrong. There are actually tables out there to kind of help get you at least closer, and that's what this thing over here is. So depending on what type of process you're using or what type of metal you're using, there's some good default places to start. Otherwise, Solidworks is going to give you a 0.5 K factor to start with on default. That's just where it is. So kind of get an idea of how that K factor is affected depending on the value, just so it makes it a little bit more clear here. We got this A, B, and C type thing. So this little arc length here, if your K factor is at 0, that arc length is going to, I guess that A arc length of B and C is going to stay the same. Likewise, if we look at something like this with a 0.5 driving down the middle, again, that neutral sheet, that kind of middle axis is going to be that spot. And then obviously if you throw it up to 1, it's going to be that whole outside face. So, but Jeff, did you have any input on any of that? Because I know they'd mentioned.
Once the K-factors are defined, like you said, you want to keep them. Block is a great resource for that already. We have developed, or they have developed and given us a chart. And for the common gauges that we bend, we already have those limits set. And you rarely have to change them no matter what material you're using, whether it's from stainless to aluminum or even mild steel. Pardon me. A lot of times, once you really don't have to change anything, even for your bend allowances or whatever, until you get beyond maybe 1/4 inch thick material. So anyway, if you can find those K factors out, you get them set. Like you said, leave them. Don't ever change them. Use them for the same gauge across the board up to about 1/4 inch all the time. And then, but if you can't figure something out, we can try to assist with that as well.
Okay, great.
So, can I ask a question? The K factor is not going to be changing with the material thickness? The reason I ask that is I have...
To a point,
yeah. It depends on the material a little bit, but if I bend 12 gauge stainless and then go and bend like 12 gauge mild steel, the K factor will remain the same for 12 gauge or 105 thickness. Okay. At least that's what we had discovered. Okay. Okay.
But would it make sense to you that if I go from 12 gauge to 7 gauge, my K factor?
Yes, that's what I mean. I just mean across the board when you're changing materials, you don't have to change the K factor for a different kind of material. I mean, aluminum, once you get above 1/4 inch, 3/8, it stretches a little bit more or whatever. But yeah, that's what I meant. So,
okay. No.
Yeah.
Thanks. So that's kind of one first one there. You're also going to have the choices of using bend allowances. So if we kind of look over at this little thing down here, the way bend allowance works is it kind of takes that outside arc. You're kind of just setting a value to it yourself, and it's going to take where the tangency of that bend actually comes to that straight. It's going to kind of stop it off. So that's what that 2.625 and 1.625 is, and it's just going to add a set value to it. Kind of on the opposite side of things, bend deduction, it's going to do the opposite. So it's going to take those full lengths, and then you're actually taking a value away from it. So you're kind of setting that and then taking it away. So like I was talking about though with the simple and varying tables, in simple, if it's, bend allowance, bend deduction, you're just kind of setting a distinct numerical value for it. So no matter what the angle is, it's always going to be X, right? The way the varying ones work is you're setting your thickness, and then depending on the radius of your bend and the angle, you're going to get a different result. So it's kind of adjusting more so to each individual bend instead of just having one stagnant kind of result. So
the number that goes in that table, what does that represent? Like for 20 degrees, you've got 1/8 of an inch thick. There's a number there. What's that number represent?
The numbers over the angle?
Under the numbers that aren't filled out, the numbers in the table.
So that's going to change depending on what your thickness is.
Oh, okay.
So since this thing is, you're choosing what your thickness is up top, and then kind of depending on what that is, that's going to set your bend allowance value. So it's going to take that and then bring it over, and then when it's going to take that number to actually unfold your part and add that bend allowance.
And what does that number represent then that you get?
It's got
bend allowance for what?
Yep, it's going to be depending on kind of whatever you end up setting your varying value to. So it's an equation in the background.
We had bend tables.
Yep.
And it was called a setback.
Okay. I think I was reading something about that. Yeah.
I
Okay.
just wonder what that number is.
I think it's just an equation that's just set up in the background. So.
Where do you use that number when you're designing a sheet metal part?
So when we were talking about, where we go? So usually there's a box down here for bend allowance.
Yeah.
So what these bend tables are doing for you is in the background, they're kind of doing some calculating and putting that and applying that value
Oh.
to that. Did that make sense? I feel like I just kind of said the same word 7 times. So, okay. If I'm talking too fast, by the way, it happens a lot. Just let me know. Just be like, Dave, slow down. So, it just happens. Okay, so the last of those things, and from what I've found and what I've talked to a lot of people about, is not a whole lot of people use these ones. So, for whatever reason, bend calculation tables are just not used all that often. But if you start to look over here on the side, you're getting kind of equations for your K factor instead. So this is kind of a constantly changing number instead of something that's strictly stagnant. So, and again, there's a lot of other stuff over here going on. If this is something you're honestly interested in, it's out there. Take some finagling if you want to work with it, but they do have the default one ready for you if you want to try and play with it. So, cool. All right. Custom properties though. So hopefully you know, anytime you start a sheet metal part, these are automatically generated for you. So they're going to be available for you whenever you want to start, I don't know, taking a look at them. But kind of going down this list of things here, bounding box length, bounding box width, pretty straightforward, right? It's just kind of that height and width of the outside most parts or edges of your part. Sheet metal thickness, straightforward. The bounding box area, so that's going to be literally the full area of whatever that length and width is. But then there's also this one for bounding box area blank. So what that's actually going to do is just take into effect kind of all of the area of your sheet metal part itself. So the only time those two values are actually going to be the same is if you're creating like a plate, something that's just filling up the entire space. So cutting length outer, that's going to give you the full length distance of the cut on the outside of your material. On the other side of these things, cutting length inner, it's obviously going to do the opposite. So if you got holes, cutouts, it's going to take the entire length of whatever those are, and it's going to give you that value here. Cutouts, again, straightforward. It's just however many cutouts there are in your part. Bends, again, very straightforward. Bend allowance, whatever that value is. Material, and then mass is going to be there. I don't know why they even fill it in when it's not a material set. To me, it should kind of just be set to 0, because then it's kind of just a visual indicator that, hey, there's no material set. This is not a valid number. So in case you bring it over to your drawing and it automatically fills that stuff in, you're not getting a incorrect value. But just one of those things to be aware of. Description's the only thing that's not actually calculated. So you can change this at any point to any value. It starts off at sheet just default. So
Are these properties in 2017 or 2016? Because I don't remember seeing these in my 2016.
they should be in 2016.
Okay.
I think even farther back.
Okay.
I'll show you where you, because later on once we actually get into the software, I'll be clicking on it and showing how you get to it. So
Is the bounding box length and width, is that the flat pattern or is that the bend? Or does that change based on?
it's the full bounding box. So like whatever the farthest reaches of your part is at some point on the height and width. I guess, did that answer your question or?
Yeah.
Okay. Cool. Bend radius. Just whatever your bend radius was set to when you started that sheet metal part. And then surface treatment if there is anything. Cost. I'm going to go over kind of the costing tool in the second session, so if that's something you're interested in. That value can get populated in there. That's not really going to be in this first session here. So, and then quantity. So, cool. Moving on to actually creating sheet metal parts, though. This is going to, again, if you've used the software before, this might just kind of be a repetition of things you've heard before. But it's going to kind of be starting from the basics, kind of moving forward. So, base flanges are obviously your base sheet metal part. Second session, I'm going to kind of go over some additional ones, so swept flanges and lofted bends. So there's kind of three main bases for actual sheet metal parts. Base flange is one, swept flange is another, and then lofted bends is going to be the last one. So think of kind of this base flange as your boss extrude for sheet metal. It's kind of the base of it all. It's kind of the way you first start creating material. You can actually use it sort of a thin material type of method, or if you're creating plates, it's always going to depend on what you're actually, I guess, what your design intent might be, what you're actually building in down the road. So, and then usually in the next step, we're going to get into edge flanges. So this is just pulling additional material off of wherever your base flange starts or whatever your beginning sheet metal piece begins. And then you're adding on material to the sides. The bends are automatically being added. That's kind of why in the beginning we set all of those K-factor values, all of those other bend values. And we'll kind of get into some more of this stuff when we actually get inside the software, so it makes more sense. It's all clicking. This is just so you kind of get, as we're starting to go through these steps, you're like, oh yeah, okay, you already talked about that. Nice thing about it is it does not require a sketch. There technically is one in the background, and we'll get into that, how you can manipulate it, but it doesn't need one to be edited. And the best use for this is obviously going to be single flanges. There's going to be additional things that we can use to have kind of stepped, like up and downs for sheet metal. And with that, you can select multiple edges. Like I was talking about, new in 2016. So as I'm going through these, this is kind of a state of sheet metal parts. So if there's new enhancements in the past, like 3-ish years, I'll include it. New in 2016, though, let's say this is your base flange. It now allows you to have that profile pulled outside of it now. You used to have to do it where you added a tab on the side of things. Now you don't have to do that. It kind of allows for a little bit quicker usage. And as I was saying, tab feature, this is just used to quickly add material that doesn't require a bend. So that's a key note to know there is doesn't require any additional bends. It's just material going on material. So if I wanted to add something like this little, I don't even know, do you want to call it? I'm just missing it. Circle. You can just quickly add that material onto the top of it. So that's going to be housed right under your base flange / tab command. So we're going to get into some corner reliefs too. You can manually add them, or these three are ones that can be included in auto relief. So as you're building your sheet metal part, you can set what your auto relief type is going to be, and it's going to kind of automatically create that as you're adding edge flanges, as you're adding miter flanges, additional items to your part. So new in 2017 though, they allowed you to have a 3-bend corner relief. So instead of kind of having, I think I've got a part on here too to show what that actually looks like, but it used to just be kind of that 2 intersection. Now allows for more of a 3-point. And then in 2014, so is anybody still using 2013? Hopefully not. Good. 2014 corner reliefs allowed for in the form that would appear in the flattened state as well. So there used to be where you could kind of only have them at one, and then you'd have to add them together. So then we're going to get into the fold-unfold step. A lot of time there's some confusion between when to use this or when to flatten things, or why this is even a thing, but it's a very important thing to know of and a very important feature to use when it's needed. It's used to add cuts along bends or seams or something that's kind of already created. A note on that is you can add cuts to your flat pattern, but it's not going to be represented in your formed, actually bent feature or part. So if you do it on there, it's not going to do anything for you. It's just going to be on that flat. Then we'll get into miter flanges. So miter flanges you're actually going to need a sketch for. And then again, you're going to start selecting edges on where you want it to be applied to. One thing to note is you have to have that sketch normal to whatever edge you're applying it to. And again, you're going to see what I'm actually talking about when we start doing these things. But it can only be swept in one direction, so you can't say, hey, just shoot this thing in both ways. So this is going to be great for creating these complex bends. Like an example of this where it's kind of 3 separate things. Normally if you did edge flange, that'd take 3 separate steps. Using miter flange, it's going to just quickly change it like that. So hopefully that's enough of me just talking. I'm sure you love the sound of my voice, but let's actually get inside here. So, okay. So let's say you're a complete beginner. You have no idea where to start on these things. Maybe your sheet metal tab isn't even available to you. So you can just right click on your tabs, go ahead, make sure that's clicked on, and then get to this thing. So I'm just going to go ahead and create a new sketch on this front plane. And then for the sake of this, I'm just going to go ahead and just do something any size here. So let's say you just built this plate, just this one piece, but down the road, or maybe your actual intent is to create like a kind of 3-sided part, 3-sided enclosure. You're kind of skipping a whole, or you're kind of adding additional steps by doing something like this. And another thing to note is over here on your left-hand side, you're not really allowed to set your bend radius right now. So we've got our thickness, we've got our K-factor, and our reliefs, but when we're doing just a plate, it doesn't really give you that option to create your bend radius. So if I go ahead and actually go ahead and delete that, that's fine. Take another way of doing this. Let's say we're going to make a symmetric part. So for this, I can actually go ahead and just snap this midpoint together. And I'm just going to use some real nice clean values here of 12 inches by 6 inches. But maybe I want it to always be symmetric, so I'm going to go ahead and just hover over this thing and convert it. So now if I actually go to that base flange and actually start to extrude this thing, I'm getting all those additional sides that I wanted. And then now I'm getting all of my options for the various different things. So before I was talking about the bend radius being hidden. When we actually got this thing where bends are included, it's going to be listed on there. So, but so we did a lot talking about gauge tables. If you actually have some, you've got them set, you've got them included already. You just toggle it on, click on that button, and we're going to have this drop down of all these different things. So I think these are the stock ones that come already loaded in SolidWorks. So I'm just going to go ahead down and choose this one. It's just a simple table. And then you've obviously got your selection for gauges. So like I was talking about, nice thing about creating your own is maybe you don't use half of these. Maybe somebody new comes on your team. You don't want to lead any confusion for them to make a mistake. You can just take away some of these things so maybe they're not clicking the wrong part. But I'll just go with my gauge 22. It's kind of where I'm just setting my default bend radius. And then there's this option here for override thickness. For the most part, you don't want to do this. There's very rare times I've seen you want to use it, especially down the road, and we'll explain kind of why you don't really want to toggle with that. It's going to cause some issues down the road with incorrect thickness between various parts of your sheet metal. But you're also going to notice this bend factor is grayed out down here. The reason for that is my gauge table is driving my bend allowance, so I don't have to choose it myself. It's already being calculated in the background. And then again down here we've got this option for a rectangular tear or a browned relief. So rectangular is pretty straightforward. A browned is kind of just that rounded type thing. And then tear is just literally, if you imagine tearing the piece apart, it would kind of create that. So we'll just leave it at rectangular for now. And then what? I skipped one thing. So if we're looking at this corner though, we do have this option here for choosing thickness, or I guess the direction for your material. So you know, if you've got certain sides that you know you're choosing your dimensions from, you can choose it from there. For this, we're just going to choose the inside. So we've got our sheet metal part all fixed up. We're going to notice two new things over here in our feature manager. One is that base flange, obviously, and then you're going to get this new folder for all of that sheet metal stuff. And so what I was talking about before is maybe you decide you go back and you need to change the thickness of this thing. If I go ahead and right click and edit feature for just this base flange, and then I come down here and I say, hey, override default parameters and change this thing, it's only going to change it for this feature. So you don't usually want to ever do this. Because each additional feature that you add later down the road is still going to be using that default that you set. So what you're going to want to do is go back up here, edit the actual sheet metal feature, change it to something else. I don't know, maybe you want 18 instead. And then it's going to be set, and any additional things that are added down the road are going to be included. So moving on though. So we've got the two sides of the enclosure. Next thing we're going to get down to is adding edge flanges on one side and then miter flanges on the other side, so you can kind of see the differences between those two. Edge flange is just up here. First thing you want to do, you just go ahead, you can select any kind of side of the edge that you're going for, because as soon as you do it, it's going to pull that whole thickness. And then with your first click, it's kind of saying, okay, that's cool. Now which direction do you want to pull it in? So you can kind of choose inside, outside. And when you click again, it's actually going to apply that length. So nice thing about this though is we've got these three other edges. Maybe I want to include those as well. And when I do that, it's going to actually add in those treatments on the edge where kind of material is not intersecting. You don't have to actually do that yourself. These arrows, if you've ever seen them, all it's going to do is flip the direction. So just quick little things there. You got your gap down here. That radius is already set for you. One cool thing though is if you want to change around the angle, you can have it go inside, you can have it go outside, but it allows you to kind of do that material change quickly without having to do a whole lot of work. Oops. Okay. So we're just gonna, looks like I clicked off it, so. Okay. Further down here though, I'm just gonna set this to 1 inch. You've got a lot of different choices for where you actually want to start that flange length from. So that outer virtual sharp is basically, if you imagine kind of where this, let's see if I can get it, where that corner of this material is, that's kind of that outer virtual sharp. It's going to change as that angle changes, right? So kind of where the material would meet. It's kind of where this face and this face intersect. So virtual sharp can change. You got your inner virtual sharp and then tangent bend. So some of these are going to look exactly the same when it's just something like a 90 degree, but as you start going around, you can change them. So and then flange position. So I did have something for that, just so you kind of see there's all these different things, and it's all going to change kind of where the material ends up. Some of them, when it's at 90 degree, it's going to be exactly the same. But there are these kind of, was it five different options. So if I start to move this stuff around, again, it's what your company might use, maybe what standards you have set in place. Just kind of one of those things to think of. But if I go ahead and click OK, you're going to notice, yuck, what's going on with that, right? There's actually an option for that to kind of toggle on to make sure you don't get certain things like that. So when you're coming to these corners, you got material coming together. When you take some away, there's still technically that little piece there, but if we toggle on this trim side bends, if I go ahead and again do that check mark, it's going to take away that material. I don't really have to worry about it. And one thing I have been forgetting to do, very much like the mantra of save early and save often inside of SolidWorks, sheet metal's kind of got the flatten early and flatten often. So make sure before you keep moving down that tree that your part is actually able to flatten. You don't want to get all the way down to the bottom and then have something all the way at the top be some type of errored feature where you're like, great, now I got to redo however many hours or whatever amount of time of work. So cool though. So any questions on edge flanges? Cool. All right. So miter flanges are going to be a little bit different. So we were talking about it. You could do kind of a couple different bends all at once. Extremely handy if you're kind of already know what you're going to be building. As soon as you click it, it's kind of wants you to select that first plane to actually start creating. So hopefully you know about this. It usually works inside of Solidworks or if you're creating new planes. But if I go ahead and when it's asking me for this plane, if I select this edge kind of near the bottom, it's going to go ahead and create a new plane normal to that point down there. So I don't have to actually add a new plane myself. Kind of auto-created that thing. Saves a little bit of time there. So we're just going to go ahead and sketch this thing up. So you're usually starting on wherever that sheet metal piece is. We're just going to do it about this. I'm going to go ahead and just make these two equal to each other. Add some dimensions on here. And set this thing to, oh, it's way off, 45 degrees. So if we move this thing around, okay, we've kind of got our kind of that shape that we want this thing to be, right? So we've now got our profile of what that edge is going to look like. If we go ahead and click out, it's already recognizing that edge is where I want it to start. Cool little button here though is if I know this thing is going to wrap around this entire thing, I've got this little button that says propagate. So if I click it, it's going to take all those connecting edges and just go ahead and apply it to that. So allows for some flexibility there. Instead of doing one miter flange, another miter flange, another miter flange, you can just go ahead and select that thing in once. So for thinking about that, it saves a lot of time. Okay. Again, using that default radius, and much like the edge flanges, we've got this option for the flange position of do we want our material inside, do we want the material outside, or kind of where do you want that different stuff located at. Again, same trim side bends. And then you've got this gap distance. It's just that gap between those two things, right? Another cool thing to note, so even though I started this thing down here, maybe I want it offset an inch or so. So you can have the start and end position of each of these things be changed. Just again, little customization things that you can work with as things go. Cool. So we will go ahead and click the OK on that. And we've got our fully constructed miter flange. That offset, everything's going on. And we can see if we go ahead and flatten our part, we got that full flatten. So as far as flattening goes, there are actually two ways to do it. We've obviously got this nice little button here. But another thing you can use is if I right click on this top face, I can go down here to toggle flat display. And if I get a preview, 99.99% of the time it's going to actually work. So obviously there's somewhere in there it's probably going to fail due to some crazy weird reason. But if I'm getting those things and it's showing me the display, it's going to work. So it's another way to see it just real quick without hammering your graphics as much. Maybe it's a really large part. That's just a quick way to see it is working. Okay, but fold and unfold. So extremely important, especially when you're adding certain cuts on edges, corners, certain places. So I've seen it before where people will use this basically just to flatten their part. That's kind of a big no-no. You don't want to do that. It's going to kind of add a bunch of resources that you don't need for basically no reason at all. What fold and unfold is going to be good for. So you're selecting that fixed face of what you actually want to do. If you can, try and resist doing this collect all bends. I know it's super easy, but again, if you got a big part going on, it might start getting your resources, and it's easy enough just to select certain edges that you want to unfold. So selecting my fixed face, selecting bends to unfold. So I'm just going to go ahead and choose these two. And then when I click the check mark, it's going to take those two and unfold them. This is then going to allow me to add some cuts to this thing. So if I go to, I'm just going to maybe make a random circle, It doesn't really matter what size. We're going to do it on both of these though. So if I go ahead and exit that sketch, ooh, okay. Right. Go back to sheet metal. If you've ever noticed this extruded cut on sheet metal tab, it's literally no different than the one on the features tab. It's just so you don't have to keep clicking back and forth between these two. So just one of those things. If I go to extruded cut though, when you're in this flattened or folded, unfolded state, one thing I'm going to go ahead and recommend to always try and use is this link to thickness button. That way if you ever change, go back, decide, hey, I want this gauge thicker or something, this thing's also going to change with it. You don't have to go back to this cut and actually start extending it. We'll go ahead and just take those two cuts out. And then once that's complete, we can actually go back to our fold step. So right away, since it already saw an unfold step above, it's going to recognize and reselect that fixed face you already had. And then you can go ahead and re-choose these bends or hit your collect all bends since everything else is already folded for you. Then we go ahead and click OK. Then we're going to have those two cuts on those corners without really having to do too much issues. So when we actually go to our flat, it's that accurate circle we were actually looking for instead of kind of that stretched oval. So if you're having issues with that, that's that quick way of kind of fixing that issue. Okay. So adding material to something that's already there. So we've already, maybe we want to add a tab onto this thing, right? So tabs are used when you don't need to add a bend. You're just adding material. So maybe like that example I showed, you want to add kind of a circle piece onto this thing. So we'll go ahead and, again, just go in here. We'll just snap it to this midpoint and make it a nice clean 1. A lot of hard numbers working with today. So, okay. If we go ahead and kind of turn this thing around, you're going to want to make sure that the material is going in the correct direction. One thing I will note is if you ever mess this thing up, like let's say I was trying to add something over here and somehow I ended up choosing this face back here and I created this tab just kind of floating in space. It's technically going to be a base flange feature, and then you're not actually going to be able to go back and change it to a tab. So there's kind of no way that I found you can toggle between tab or base flange features. You're just going to have to go back and recreate it. And that can cause some issues because if there's a second base flange in here, then you're going to have 2 sheet metal parts technically, and then some additional things can kind of cause errors from there. So, but that tab is just used to add quick material onto things that require no bend. Okay. So let's say we want to actually add another flange to this bottom edge here, but for this one, maybe it's not going to be the full size of this part. So we can go to this Edit Flange Profile option, and it's going to bring up this sketch. It kind of looks a little dimensioned, but there's nothing really going on in there, so we can actually start dragging and moving this thing around. And I can start using all of my sketch commands in here. So I can start adding dimensions to this thing. 6 by 4. Maybe you even want these edges filled for whatever reason. And then another cool thing is you can actually add cuts into this at the same time. So if I want maybe 2 holes going at each of these radii, I can go ahead and click OK. When I hit finish, I'm going to get this fully new flange pulled out. It's got my cuts in there. Everything's already applied. Go ahead and look at my flat. Boom, that thing's working. So pretty cool way to actually just add things in there without having to have a full flange profile and then cut it out and then add some other things in there. You're also going to notice it added those rectangular cuts that we were talking about earlier. That's that auto relief working for you. And then this is kind of that bounding box I was talking about before. So anytime you're in that flat, if you ever want to see what that full length is, you can just click that line, and then this bottom right, it's going to tell you whatever it currently is. So Okay. Where are we at on time here? 6:40. Okay. So, getting pretty close here. I think last thing I got for you is we're talking about those custom properties, right? So that's going to be listed up here under your cut list. And then if I right click on, if you got multi-bodies, whatever sheet you want to look at, I can click on properties, and then I can get that full listing of all this stuff, and kind of all that information that I got going on in there. So
the custom properties are still into a cut list, not in the custom property.
correct. Yeah. So it's not, if you go up here to this top, whatever properties thing, it's not going to be there. It's kind of distinct specifically for the sheet, and I'm going to show you how you can get access to that stuff in the next session for when you actually bring it to drawings, because right here it's not doing you any good, right? But once you actually bring it to drawings, it's going to start working for you. So
Can I ask you a quick question? When you flatten them out, where it shows all the cuts and reliefs and whatnot, everything is rectangular. Okay, when I'm buying laser cut parts, the guy says I don't like square cuts. I like everything to be radius.
Mhm.
I got to go back, and that's what the ob round and that.
yep, that's what those different choices are. Another thing you can do, because right now it's not showing my actual relief, right? That's something that you can edit in your actual flat pattern feature to show it or not show it. But if you like that, you just go back up to the top, that sheet metal feature, say edit feature, maybe go down here to round, and then change it. There's
Put it wherever it belongs.
yeah, and then there's going to be other ways that you can add additional corners. So I think I'm going to cover this in the next one. You can add corners specifically to your flats or to your formed feature. That's just kind of two different ways. Maybe you just want to have a tear going right now in the formed state, but when you actually get down to it, you want to have it something else. That's going to be here under this corners thing. You can start to go to corner relief, and then start actually choosing the corners that you want to add. So,
Fix it all later. Okay.
yeah. So,
Back to your gauge table. Can we talk about that for a second?
yeah.
So like we just talked about, we have a changing K factor for the gauge of the material. So my 7 gauge has a different K factor than my 12 gauge is different than my 14 gauge.
Yep.
Does that mean I need a gauge table for each thickness, material thickness I'm going to use? Because that gauge table only lets me set 1 K factor, correct?
For the most part, when you're kind of in these similar thicknesses, the K factor is going to kind of stay the same. Let's see if I can get back to that slide we got going on here. Because it was... where are you? There it is. Okay. When we're looking at this thing,
Yep.
this is just one. So this is just one material type, and it's 1 K factor for all of these gauges. Right?
No. For each.
Oh, you want them specific for
Yeah.
each one.
Because
yep.
I'll give you an example. I do machine design.
Yep.
I'm going to bend up a 90-degree bracket. I'm going to put a Keyence laser sensor on, and it's going to detect a part.
Mm-hmm.
If I use the K factor for 12 gauge sheet metal on a piece of 7 gauge, it's not going to come out the right height. I'm going to be off by 1/8 of an inch.
Okay.
When you bend 20 brackets in the machine, and someone pays to have them laser bent and burn,
Yeah.
and none of the sensors hit, I tell you that's a real fun phone call.
Yeah. Definitely understandably so. So that's probably where those varying tables are going to come into play.
Okay?
So it's changing. You can kind of see this changing by the thickness, and it's even changing by whatever radius you have set to it.
So that's a K factor that's getting put in there.
You can change it by bend allowance, bend deduction, or K factor. That because right up here it's saying type,
Okay.
so you can kind of change it around.
No, perfect. That's the question. Thank you.
Yep.
We handle that kind of by using different radiuses for different gauge.
Correct.
So we're using like the K factor .025, but then we're using different radiuses for different gauges.
Oh, I see what you're saying. So if you're going from 12 to 7, you're changing your radius to keep it constant. The particular person that I deal with likes to use Someone says I want you to supply everything.
Wow.
Okay.
Okay.
Cool. So that's kind of what we had for session 1 here. When we start looking at session 2 here, so that's going to be, I don't know, is it 30 minutes from now or something? Going to get more into drawings and flat patterns, actually working with some of that stuff. And then it's going to be some more, you can call them advanced sheet metal parts, or sorry, features. I don't know, apparently I forgot to check that. It's supposed to be features. So those lofted bends, some of the other stuff. And then we're going to jump into the costing tool and then converting to sheet metal from either dumb solids or maybe just a already thick part. So, but thanks for sticking in for the first session. Hopefully learn something from it. So.